Here's some background information you might not know about buoyancy. When an object is submerged within a fluid, forces act on the surfaces perpendicularly. Those forces acting across the surfaces create pressure. Pressure is a force acting across an area. In this case, the force is the weight of the fluid, shown as mg. The area is the surface of the object. But before I can continue, I need a relationship between density, mass, and volume. You might remember from earlier lectures that density equals mass per volume. I love density is an easy way to remember that formula. If you rearrange that formula, you get mass equals density times volume. Next, use the density formula to substitute mass with density times volume. Volume is three-dimensional, area is two-dimensional, 3 dimensions divided by 2 dimensions is 1 dimension, or in this case, height. Here's the formula for pressure caused by a fluid, and you can see that the pressure changes with changes in the density of the fluid, represented with the Greek letter rho, the gravitational acceleration, and the height of a fluid above the point of interest. For that reason, the pressures acting on the object at equal depths have the same magnitude. If two of the pressures at the same depth are opposite of one another, they cancel each other out. In other words, the object feels pressurized from those forces, but does not accelerate due to those forces. Mathematically, the net force from a fluid is 0 in the horizontal direction. The top and bottom surfaces of this object are at different depths, so they will experience different pressures. I'll call this P1 and P2. P2 is at a greater depth, so the resulting pressure is greater. Buoyancy force acting on the object is simply the summation of forces caused by the fluid in the vertical direction. I'll define up as positive. I can rearrange the pressure formula to get force equals pressure times area. Basically, the force causing P2 is P2 times that area. Same thing for P1. Notice the force causing P1 is negative because I defined up as positive. The resulting net force, known as buoyancy force, is acting upward because P2 is greater than P1. If I substitute P1 and P2 with the formula that I derived earlier, I get this equation. I can assume the density of the fluid and the gravitational pull are consistent above and below the object. For that reason, I can factor out density and gravity from the equation. If you look back at the diagram, the difference in depths is the height of the object. The height of the object multiplied by the cross-sectional area is the volume of the object. In this case, the volume of the object equals the volume displaced because the object is completely submerged. Therefore, the buoyancy force equals the density of the displaced fluid multiplied by the volume of the displaced fluid multiplied by gravity. I can plug that into the buoyancy formula to get buoyancy force equals mass of displaced fluid times gravitational acceleration, otherwise known as the weight of the displaced fluid. If I had to summarize buoyancy in one sentence, I would say, the buoyant force pushing an object up has the same magnitude as the weight of the fluid the object displaces. Thanks for watching. If you need help with math or physics homework, email me at swinson.university@gmail.com.